I have an interesting model here. It's actually an assembly made up of a bunch of different parts. It's an exhaust manifold from my engine, and there's a flange here which fixes it to the cylinder head, and then there's a number of elbows. And the way that these things are fabricated in these sort of performance parts is that they're actually weldments containing a number of different parts that are then welded together, and this is the collector where all the 6 pipes come down into one. And I'm interested in a few different aspects of this design, and I'll show you how that works with Creo simulation live as part of the environment. Now, the first thing I wanted to show you is the fact that I've got a measurement of this pipe, because it's a critical length to me for the performance of this engine. So I've actually saved these measurements as analysis features. This is a pretty powerful and maybe unique feature of Creo to be able to put any type of analysis and encapsulate that as a feature in the model tree. And you can see here that the current length of this pipe is 216 millimeters. And on top of that, I'm going to define myself a sort of criteria, a design criteria for the length of this pipe. I'm going to use the performance monitor, which is part of the BMX tool set in Creo. And I'm going to create a condition which says I want this length to be less than 175 millimeters with a tolerance of something. And you'll see here immediately that the status goes to red, because indeed 216 millimeters does not meet this criteria. And as I close that window, you'll see that the status is down here in the message part of the toolbar. This is a very useful thing to have running at all times. Now that I'm sort of thinking about a number of things at once here in this design. I'm thinking about the pipe length design, I'm thinking about the weldments and how I'm going to manufacture it, but I also want to look at some of the simulation and performance characteristics of this design as well. And this is why Creo Simulation Live creates a perfect environment for this, because it sits right in the design environment, and it allows me to start setting up analyses in a minimal amount of effort. I'm going to do a modal analysis just to get a sense of how stiff this part is. And once I've defined this very quickly, I'm going to just up the accuracy a little bit there. That's right. So very quickly we get our results feedback. And this is the bending, kind of the first bending mode. This is the second mode of vibration at sort of 1,000 hertz. I'm going to flip through a few of the modes and see, they're things as expected, but this fundamental frequency at 574 hertz, I just wanted to make sure that that was not going to lie into any particular harmonic that I would be worried about for this engine. So I always pretty much start with modal analyses when I do this type of thing. Once we've got this first analysis done, I can then set up my first stress analysis. So I'm going to again fix this face just for the purposes of this demonstration, and then perhaps put a force up on where the catalytic converter up pipe would be mounted. And as soon as we start the simulation, we get pretty much instant feedback, and this feedback will stay here as we continue to do the rest of our design work. Now, there's a couple of problems. The first problem is our performance monitor is still showing me that this pipe is too long. The second problem you can see straight away is that there's an interference between these cylinder 1 and cylinder 3. So we're going to have to address both of those. And what I'm going to do is try and make this pipe come down at a steeper angle, and then maybe turn a corner a little bit sharper angle. At the moment it's turning through about 45 degrees. Maybe I want to go it through a 90-degree bend. So I'm going to show you something nice because we are still in the design environment. I can access all of the powers of Creo's assembly modeling. I'm going to do an instance replace of this component from another of my library of elbows. Typically I'd have these kinds of parts libraries because I do this kind of fabrication all the time. And I'm going to replace that with a 90-degree bend. And you'll see as soon as I've added it, we've solved two problems at once, which is actually really interesting. Firstly, you'll notice that this performance monitor has gone green because the new length is 172 millimeters, which meets our criteria. That's great. We've also addressed the interference problem between the pipes. Maybe there's a little bit more we could do, so I'm going to just adjust the angle that this comes out a little bit more, maybe 60 degrees, and when I regenerate that, again you'll see that now we're on a little steeper angle, and the results are there for us. Now, I've kind of had these stress results in the background, but I've been keeping an eye on what these maximum stresses near the worlds are, because that's obviously going to be absolutely critical to me for perhaps fatigue life of my design. But the point of Creo Simulation Live is that you can have these, whether they're stress analysis results, whether they're modal frequencies, or whether they're deformation and displacements. These types of results can be completely incorporated into your design environment while you're doing all of the other simultaneous problem solving that real-life engineering involves. And so Creo Simulation Live adds a lot of value to people who are doing anything in the design environment, whether it's new designs or modifying existing designs.